just to introduce the four people who you can hopefully see on the screen. My name's Matt, although it says Xcede Recruitment, I'll change that in a second. Part of the data science recruitment team at Xcede. I'm working alongside Niall, who will introduce himself in a second, and two other guys, James and Callum. We wanted to do these webinars, so we do our own networking events, as we were just talking about now. Try and do them annually, but given everything that's happening, we've been a bit restricted to do that this year. So we were still keen to try and put something back into the wider data science community through the technical talks that we normally have with these. And Rushan and Mark, who we'll talk about in a second, have kindly offered to do our first ever webinar. So hopefully there's no teething issues or technical issues that we have with it. So fingers crossed. Just before the three guys introduce themselves, just a couple of housekeeping rules. We think we've set this up as a webinar dedicated Zoom session, so it should run smoothly, but we're going to do, Rushan's going to do his talk, which should be about 15-20 minutes or so, and then we'll allow for 5 to 10 minutes for questions and answers after that. But feel free, there should be a button on your screen that's Q&A. If during the talks questions pops to mind, feel free to chuck it into the Q&A section, and then we'll go through them at the end of each talk. There is also a raise hand option, but I think we'll park that for now. The Q&A function should be enough for what we need. Again, everyone should be muted automatically, but if not, please just click the mute button on your screens just to make sure. And one final thing to mention, if you go to the very top, the speaker view, although, yeah, I'm sure you probably just want to focus on the one person speaking, to make sure you press that speaker view rather than the multi-screen one. I think that's pretty much it. I'll let Niall introduce himself, and then Rushan and Mark can introduce themselves, and we'll get going with the topics, if that's all right with everyone.
Yeah, not too much more to add. Help Matt in the data science and engineering team on recruitment side. Just one thing to note, we've been asked by marketing to mention that I believe this call will be recorded. So if you want to go back and look at the session after, or share it with colleagues who might be interested, or other people who might be interested in volunteering, as will become clear later, please do contact us and we can show you the details of that.
Okay, and if I give a quick intro on myself, so yeah, my name is Rushan. I'm a senior data scientist at Builder.ai with a background mainly in control, and that's kind of the gist of my talk in a bit. Yeah, that's me.
Hi, I'm Mark. I'm the founder of a machine learning company called ContextCat, but I've also now founded a new organization called COVID Tech Support, which has been providing tech help to projects that need people like us. And I'll be talking about what can the data science community be doing to help out in the COVID-19 crisis.
Awesome. Thank you very much, guys. Rushan, would you mind kicking us off and sharing your screen? And then, as I said, we'll allow for some Q&A at the end. I'm sure we'll get more people join as we go through, but if we get started, then people can chip in as and when.
Okay. Can you see my screen? Better just check that first. Okay, brilliant. Okay, so yeah, so my talk's going to be around COVID-19 policy guidance and how you can use essentially optimal control techniques to try and decide, how much social distancing you require, given some constraints. So what's the question I kind of was trying to answer with this piece of work? It was, well, when and how quickly should governments relax NPIs in order to minimize economic disruption whilst ensuring they do not violate the capacity of the healthcare system? So an NPI stands for a non-pharmaceutical intervention, and it's basically the technical term for social distancing measures. So, full lockdown being the strictest, and then you have kind of relaxation, so opening or closing schools, people standing 2 meters or more apart, etc. So, this is obviously very topical, so I'm sure people are fairly familiar with, the kind of gist of what this problem is. So many governments now are under lockdown measures, and they all have this issue of how quickly should they lift them without breaking their healthcare systems. So a quick agenda. I'm going to cover these sort of points in the order you see them at a fairly high level, but at the end, on my last slide, there's a few links to references if people are interested, and I'm sure the guys at Xcede can fire them off to people if you want to find out a bit more about any of these topics in particular. So I know a lot of people are coming from the data science community in this talk, so you might be more familiar with reinforcement learning as a concept. So reinforcement learning and optimal control are essentially trying to solve the same problem. They grew out of two slightly different domains. So reinforcement learning typically came from the computer science domain and tends to focus on model-free methods and kind of learning within simulation through trial and error. And optimal control tends to use model-based methods. And over the last few years, they've kind of really they've merged. So some AI RL techniques use model-based methods, and some optimal control techniques now use rollouts and sort of sampling from simulation. So the base problem is known as a Markov decision problem, and it's fairly straightforward actually. It's given a state that you're currently in, you can apply a control at each time step, and that will take you to a new state. And in applying that control, you incur some cost in that state transition. And the idea is you either are trying to minimize your future cost, or you're trying to maximize your reward. So the optimal control community tends to use the cost sort of perspective on this. Reinforcement learning, you tend to try and maximize reward, but it's essentially the same thing, just different notation. Virus spread can be modeled in various different ways, and one of the most common ways is to look at a population level. So this is a common model that's actually been used by government and epidemiologists. It's known as the SEIR or SIR model, and it looks something like this. So you have some proportion of the population that's susceptible to the disease. At some rate, they become exposed to the virus. After some time, they're infectious, which means they display symptoms, and they also can infect other people. And eventually, the majority of people would recover. So that's a standard model. In my work, I added a fifth state, which was how many people from within the exposed population actually require an ICU bed. And there's and you'll see the reason I did that in the next couple of slides. But without sort of wanting to delve too much into the equations, I just wanted to point out two sort of key points. So one is the reproductive rate R of the virus, which is essentially a component of this beta here, which controls a rate at which susceptible people become infected. That is what you'll have heard of, in the media basically, and it's what governments are trying to reduce below 1. So if this is below 1, then the virus is essentially decaying. The rate of spread is decaying. If it's greater than 1, then it's exponentially increasing. So the standard R0 or reproductive rate for COVID-19 was found to be around 2.4 from data that's using data from Wuhan in China. But there's quite a lot of uncertainty around that. The second important sort of parameter in the model is this U. So that's effectively the social distancing parameter. So if I increase U to 1, which would be 100%, 100% social distancing, if you like, you would get no infections. And similarly, if I reduce U to 0, you would just be the rate of infection would be the same as the base rate. So the U is kind of a mapping from the MPI, the level of the social distancing that's applied to the R in the model. Okay, so this graph has, I think, probably been widely seen, or some form of it has been widely seen in the media or otherwise. So you can see what happens in this model as you propagate forwards in time based on how much social distancing you apply. So that the level of U. So with no social distancing, you can see you get a big peak in the number of infections. Obviously, with social distancing, we essentially flatten the curve, which is what governments have been trying to do. And what you find is, as the disease progresses through the population, at some point, naturally, the R will go below 0 because enough people will have had it and built up immunity. There is a slight issue with COVID-19 in that we don't actually know how long immunity lasts. So it could potentially be that people who are recovered might go back into the susceptible part of the population. But that, I think, is highly uncertain at the moment. So there's ongoing sort of medical studies around that. So from the model that I used, which had that extra hospitalization parameter, you can see what happens if we essentially, again, have no social distancing. So in these three graphs on the left, the bottom one is the amount of social distancing applied. So in the left-hand panel, it's essentially 0. The second graph shows the amount of people that need an ICU bed, so the blue line. And I've also put a black line on, which is a peak bed capacity. So this is something like the capacity of the healthcare system. And typically for European countries, we have around 20 ICU beds per 100,000 of the population. But of course, that's different for every country and differs if you open more hospitals, etc. But just to show the principle, I've set it as 20 for the purposes of this work. And the top graph is similar to the previous graph. So you can see how many people are susceptible and how many people have recovered from the infections. So you can see on the right-hand side is what we can see is if you apply social distancing, we start to flatten the curve. But if you reduce the social distancing to 0 too early, you get this second wave. And that's pretty much exactly what governments are trying to avoid at the moment, which is why they're very cautious about lifting lockdown measures. So this second peak is something we don't want to see. Okay, so policy. So as I said, the kind of question we're trying to answer is how do we control the MPIs to prevent the capacity being exceeded? So Imperial College, the rapid response team for COVID-19, who are doing a lot of the work for the UK government, one of the strategies they proposed was this kind of lockdown on, lockdown off strategy. So you can see you decrease the rate and you use thresholds to decide when to have lockdown and when to take it off. So this is known as bang bang control in the kind of optimal control community, and generally isn't a great strategy even for controlling systems, because you can easily sort of overshoot your constraints. So, and as an actual policy, people going from lockdown to not being in lockdown back to lockdown could be pretty difficult to implement realistically. So the idea in my work was to use feedback control to try and meter the MPI. So there's a couple of things you need in order to do that. One is an estimation of your current state. The second thing is, so when I say the current state, the current number of people who have the disease or have had the disease. Then you need some way of mapping the MPI, so the social distancing effectiveness, in the model. So what does lockdown actually mean for that parameter R? And the control framework. So I'm primarily going to concentrate on talking about the control framework and come back to these 2 points towards the end. So if you've come across model predictive control before, you might have seen a graph like this, but essentially it's actually quite a simple concept. So we have a time-based system described by those ordinary differential equations. we discretize the problem in time, and then we optimize. So what we do is we formulate an open loop optimization problem, and because our ODE is nonlinear, it's a nonlinear constraint problem, and solve it using a technique called direct multiple shooting. And the way I set the problem up, my aim was to minimize U, so essentially minimize the economic impact of social distancing, whilst trying to stay within the ICU bed capacity constraint of the healthcare system. Now that's applied as a soft constraint because you might not actually be able to satisfy it. So it actually sits in the objective, but you can think of it as a constraint. So in model predictive control, we solve for the current initial state, which will be the current number of people essentially that have had or currently have the disease. You apply the first control input, and then you re-optimize. So we would apply, our MPI for a week, 2 weeks, 1 month, and then, we're basically reformulating and resolving this problem. And that's essentially how we get feedback into the system. So just tackling the open loop optimization first. So again, if we look at the left-hand panel, you can see what happens if we try and minimize U. So we're essentially solving this problem and letting U, the social distancing, be a free variable in the optimization. So here, again, I've got the peak capacity constraint at 20 beds, 20 ICU beds per 100,000 of the population. You can see if we start social distancing quickly enough, we actually can stay below that peak capacity. And I should say here, it doesn't actually go up to the boundary because I actually set the constraint to be 90% of the peak bed capacity. So it's actually at 18. It's trying to stay below. So in this case, if our social distancing effectiveness is as good as 50%, so which roughly means from the start halving that reproductive rate number, we can stay below the bed constraint. On the right hand side, on the left, I've only allowed 50% is the max we're allowed. So that you could assume that's something like max lockdown. On the right hand side, I've maxed it out at 40% just to show the difference. So let's say this is lockdown, but people are allowed to exercise once a day, something like that. You can see actually just that small change in that parameter U, the max allowable for that parameter, shows that you quickly actually or fairly quickly exceed your capacity constraints. So these are people who essentially wouldn't have ICU beds, and then on the other side, you can see how the MPI is slowly metered to keep us, once we're below the constraint, to keep us at that level before herd immunity effectively kicks in, and at that point R is already below 1. So naturally the system tends to decay. So if you take an open loop optimization, as I said, with the MPC method, we basically rerun that at every time step. You can simulate what would happen with some noise in the system. So on the left-hand side, I've essentially done something similar to the open loop case, but we're re-optimizing at every time step, and we've added some non-adherence to social distancing, some randomness basically in our input. So you can see the U actual given by the orange is below the U opt, and I think in this simulation it's something like up to 10% it can be below. So this is would essentially be modeling people not adhering to the social distancing policy. And you can say, and the idea of closed loop MPC is even with this kind of noise, we can still meter the MPI slowly and stay within the constraints once we're below the line. On the right hand side, I've added another sort of dimension, which is that the constraint actually changes in time. So it's time varying constraint. And this essentially models the ability of government to, open new hospitals or open new clinics that can deal with ICU patients. So if you can see that over time, you can increase your ICU bed capacity, you can again do a better job of staying underneath the peak capacity. But I think the key thing to note really is that what we're trying to do here is say that it might be, or a sensible approach is to actually ease off the lockdown slowly, and use feedback control to control the level of the MPI. So, at each of these time steps, you take the current state and decide whether to actually go to the next step down, or whether to, stay where you are, or even to reimpose a stricter lockdown. But you do all of this gradually, rather than using this kind of bang bang approach of having no lockdown and then lockdown. Okay, and this is the final sort of slide I wanted to just chat through. So this is a really interesting piece of work done by Ioni Nazarathi and a bunch of mathematicians from, I think, from the US and Australia, known as SafeBlues. So one of the issues you have with COVID-19 is actually to get an estimate of your current state is quite difficult, because all our data is lagged. So we only have test data from 5 days back. So dealing with lagged data means you need some way of estimating or predicting your current state. And the second challenge is actually how do you map an MPI to a social distancing effectiveness parameter in the model? What does lockdown actually mean in terms of you? What does opening schools mean in terms of you? So they had this very sort of clever idea of actually infecting people's phones with fake viruses, and those viruses would have different properties. So some would be more contagious than others. So some would be more contagious than COVID-19, and others less so. And seeing how they propagate through the population using Bluetooth as different types of MPIs are applied. So what you can do with that data is you can, two things actually, and both of them are necessary for then building a controller. The first is you can estimate the current state of the disease, so you can use neural networks and train them on these ensemble of strands, and you can, and together with the lagged COVID-19 data, you could get a better prediction of your current state. And secondly, you can parameterize the uncertainty in the ODE model, use neural networks to approximate that uncertainty, and that gives you a way of mapping the MPI to the U in the model, so that you actually have a good estimate of what level of lockdown you need to keep yourself below the capacity constraint. So yeah, that's it for me. I have just put a few links up on this last slide. So one of them is to the original blog post, which goes through this, what I've just talked about in a bit more detail. And there's also the code there. There's a few of the references I've kind of mentioned through the slides. And also, if anyone's interested in contact tracing frameworks, my company Builder.ai, they put together a sort of proposal for contact tracing sort of software framework, which is an interesting read as well. So yeah, happy to sort of take questions.
That was really good. Thanks, Roshan. Yeah, as I said, if anyone has any questions, please do pop them in at the bottom. There's a Q&A tab, so type your questions in there and we can read them out. I had one burning question the whole way through, and then you addressed it in the last slide, which is how you, as accurately as possible, estimate the value of U, especially with the time lag as well. That must be one of the hardest things to do.
Yeah, so it is it's very difficult, and I think whatever estimate you get is going to have quite a large amount of uncertainty. They're currently doing doing that in government, so they must have some methods, and there are prediction or estimation techniques you can sort of throw at the problem, and a lot could be machine learning based. Having the SafeBlues approach is nice, because I think it would actually tighten those uncertainty bounds quite a lot, because you will have all this extra information coming from those different strands, which will tell you, essentially what's, if we've implemented lockdown in the first phase, a full lockdown for 3 weeks, what level of contact did people actually have? And because that's not lagged, so you have, you will have that day to day, those SafeBlue strands, the information from those, that can give you, I think, a much better estimate of the current state of the COVID-19. But I mean, that's not been implemented anywhere yet, but it'll be interesting to see. I know they're thinking about using that potentially in Australia and the US. So
we have a question come through. So thanks, great presentation. Does your model have any geolocation or demographic data?
So in what I've discussed here, I haven't used sort of geographic specific sort of data, but I think if this was implemented in reality, you would use basically geography. So what you'd want to do is have local kind of local estimates of your RT, maybe regional or citywide, and you could split then the MPIs between regions. So, for example, London, if it's harder hit, can have stricter MPIs than Manchester, etc. So you need to tag, obviously, the test data to be localized. But if you can do that, and certainly they must have localized data, you could use it at a local level.
Great, thank you. One final question from me. I don't know whether you've put all the references at the end of your presentation. In terms of where you've been able to get data sets from, whether that's anything from the number of ICU beds in the UK, where has it all come from?
So for most of my work, I use the Imperial College. I think, that final link in the references. I used the data that they've shared on the website, or their papers. I think, again, to implement this in an actual system, you'd want to, you'd have to build APIs to the actual where the data is being collected. I know the government has got an open data for COVID-19 site up and running, where I think quite a lot of testing data and localized data is coming. So it might be possible to actually get data from there to apply to the problem.
Awesome, thank you. I think that's it in terms of the Q&As. No, thank you very much. That was really good, Roshan. Thank you. Mark, do you want to take over from here?
Yeah, that sounds great. And thanks, Roshan. That was super interesting. I was really curious to see all of that. Let me just share my screen 1 second. Yeah, you seeing that okay?
Yeah.
Yeah, brilliant. Great, thanks for coming and joining the webinar. And I'm going to be spending 10-15 minutes today talking about what we, the data science community, can be doing to help out during the COVID-19 crisis. So it goes without saying, we're in the midst right now of an unprecedented crisis that's affecting our health, it's affecting our livelihoods of everyone. And in such times, many of us want to step up and find ways to help, but it's often the case that we don't know how. So in this talk, we'll be covering, what are ways that we data scientists can be helping, in particular with COVID-19 and beyond. And in a nutshell, what I'll be showing is that, we in the data science community have a rare skill set that is highly valued at the moment. But the problem that exists is that the people who need those skills don't know how to find us. And it's, from experience, I think it's usually the case that we don't know how best to apply our skills as well to real problems that need them, that are going on in the world just now. And also, another point is that we also have skills beyond data science that are also highly valuable at the moment, and we should be using them if possible. So, to get started, we, take a look at the world that we're in just now. We've kind of got a bit of a melting pot where we've got this virus that doesn't have a cure. The virus is causing our health services to be overstretched. We've got essential work. We're all relying on essential workers. The only means we have at the moment for combating the virus is the social distancing measures that Rushan talked about. And that means people are being forced to stay at home. It means there's furloughing and unemployment. And a lot of people are being put into high stress situations and circumstances they never contemplated being in at the beginning of the year. And who this is affecting in particular are charities and support services, which at the moment are suffering from this almost like triple whammy of their services are now needed more than ever. There's a lot of, nationwide mental health problems, physical health problems, people who are in poverty, who are struggling to get food, who are struggling to support themselves, and they're turning to charities and their communities to support them more than they've ever done before. So the services that are already out there dealing with this kind of stuff have never needed their services. Their services have never been as needed as they are right now. At the same time as this, their funding is drying up. Their traditional sources of funding, such as charity shops and so on, have all closed down. You've got events like the London Marathon not going ahead, meant millions of pounds didn't go to charities that would have otherwise been fundraised. Not to mention everybody's tightening their wallets just now because they're all in their own situations. So these services are being relied on more than ever, but their funding's drying up. And then on top of that, they are all forced to move to digital all at the same time without much support in doing that. There's a lot of charity and support services that are used to doing things in person or with people on the ground that are now having to move to video or websites or apps and don't have a clue how to do that. It's a broad generalization, but most of them don't have much digital experience. And going digital was something they kind of thought they knew they needed to do at some point, but now they're all forced to do. So those two things combined have meant that the support network that is out there is sort of at a critical point at the moment and needs as much support as possible. But at the same time as all this, we're also in a situation where over 9 million people in the UK have been furloughed. A lot of people have been made unemployed, possibly some people in this chat as well. What this means is you've got a lot of people with a lot of ability who are stuck at home with nothing to do, free time in their hands, and the potential to help out. And on top of that, you've got people like ourselves who, even if we are in employment, we want to make a difference, we want to put our hands up and help out, but we may not necessarily know how to do that and where to start. Because there are so many problems out there, it's difficult to know which one to pick and how to get going. So what can we do? So let me start by explaining a bit about myself and what I'm doing, and then how that can help you guys helping with COVID. So I started a project when the pandemic started called COVID Tech Support. COVID Tech Support finds tech talent to help nonprofits, charities, and COVID projects get up and running. Every day, our community of over 1,000 talented volunteers from all around the world are helping with projects that are dealing with the worst of the pandemic. And now COVID Tech Support came about 2 months ago at the beginning of the crisis, where me and some entrepreneur friends of mine thought, hey, there's probably something we can build, something we can do to help out in this crisis. So we started a Slack channel and started inviting our friends to join us. And before we knew it, we had hundreds of people in there. So we realized, okay, there's a lot of people out there who want to be helping right now. And one thing I noticed pretty quickly is that all those tech people started talking about things they could build, and there was a real disconnect between people actually experiencing problems on the front line, such as healthcare workers and communities, and what these guys were discussing in this chat. And so I realized there needs to be somewhere where the people who are experiencing problems can tell us those problems so that the tech community can respond accordingly. And so I set up the COVID Tech Support website to be a sort of help desk for anyone who's non-technical, who wants technical help. And at first, when people made requests through the website, they would just go to me and I would deal with them. And this became unsustainable pretty quickly. So I started asking the Slack channel if they could help me with some of these problems. Hey, I've got this project that needs a web developer. Could you come help out? And that worked really, really well. And so I realized that COVID Tech Support was the sort of bridge between these problem requests coming in and this community. And by this point, this community had grown to hundreds and hundreds of people. It now stands at over 1,000 people, and it calls itself Code for COVID, which you may have heard of. And it has people with all sorts of skills. It's not just tech. There's marketers in there, there's designers, but there's a lot of data scientists in there as well, and lots of people from almost every company you can think of: Google, Microsoft, Facebook, etc. All helping with projects that come in. Just a little bit about my background as well. Before starting COVID Tech Support, so I did a PhD in reinforcement learning and information retrieval at UCL, which I finished in 2015, and that work was on I was predicting web searches for search engines, and that eventually spun out into my own company called ContextCat that I've been running for the last 4 years, which is an intelligent assistant for the web browser. The idea is that when you visit web pages with this installed, it can comment on those web pages automatically and start finding information to help you in real time based on what you're doing. For instance, if you're shopping on Amazon for a camera, it can do things like fetch reviews for that camera online, or social pictures and social media, other prices, etc., etc. That sort of had its ups and downs over the last couple of years, and in 2020 was looking like it was starting to wind down a bit, and then the pandemic hit, and we ended up, me and my co-founder, furloughing ourselves because it didn't make sense to try to keep pushing on this business while this pandemic was happening. And also, me and my co-founder just wanted to help. We felt that was the most important thing we could be doing with our lives right now, rather than keep trying to push this thing out. So it was with being able to furlough ourselves that I've dedicated myself full time to working on COVID Tech Support and getting this off the ground. And like I was with him, he's been working on some other projects. So one sort of side note there is, right now I do a lot of the matching of project requests coming in to volunteers that can help them manually. And I have often wondered, could I be using a bit of machine learning savvy to do that? But my product experience over the last couple of years have told me to not even go anywhere near that. If it's working manually and doesn't need to scale right now, it's fine. I've ended up, I have a team of 12 volunteers now who help me match projects. And, I think the Xcede guys will probably find it quite funny to think that we've almost become like a recruitment agency in matching these projects to volunteers. But one of the things that's been really great about being in this position of running COVID Tech Support is I've now seen firsthand hundreds of projects that have come out of this crisis needing help. And in particular, I wanted to highlight some of the ones that we've been able to successfully match data scientists to. And I think they're doing some really cool things. And also serves to highlight that working on a data science project doesn't necessarily need to be about viral data or RO or anything like that. To give an example, we helped a project called Safe Steps, which before the pandemic was an app that allowed care homes to do personalized risk assessments for the elderly to make sure that they didn't fall. And with COVID being incredibly deadly within care homes, they decided to make a new app as part of that for tracking COVID illnesses and things like that in care homes. And so they wanted a data scientist to help them manage and analyze the data they were getting from care homes to make a dashboard that care homes could use to do risk assessments for COVID, not just for fall hazards. So hugely important given the mortality rate in care homes at the moment and the government's bungled response on that. Another app that came in quite early was COVID Watch. So this is before a lot of the contact tracing stuff started to come out, but what they do is anonymous mobile alerts for when COVID is detected in your area. So again, we got them some data scientists that could just look at geographical data. I think they were working with the NHS to get some data there. But that's kind of one of the projects that's been really growing and being used quite a lot. And then this final project, which is is something we see a lot of, which is a project that you wouldn't necessarily think is COVID related, but actually has been massively impacted by COVID. It's a charity. In this case, I've picked the Cumbria Alcohol and Drug Advisory Service, but we've had several similar requests from drug rehabilitation services across the country. And in this particular example, the problem a lot of these services have is, they're helping with the rehabilitation of drug and alcohol addicts. And a lot of what they used to do was in person, including keeping track and tabs on recovery efforts. And now this all needs to happen remotely, also at a time of increased mental stress. And what we've ended up doing with them, for instance, is helping create an app where the addicts can sort of keep track of their recovery efforts, and the carer can keep tabs on them and ask them to check in on a daily basis or on a weekly basis or whatever. And they wanted a data scientist to look at this data to understand when it looked like an addict might be looking like they're starting to relapse, when an intervention might need to be made based on the data they were getting. Maybe it's a lack of data that's coming through from the addict, and that's a sign that someone needs to check in on them. So that was an interesting project to help with as well. And there's a couple of other projects too, which those are all ones that have been matched with already, but we have new projects coming in that are in the process of being developed, where data scientists can help. One of them is called Testing for All. It's a charity that's been started by the founder of CloudReach, and he's trying to ramp up the amount of antibody testing that we're doing to hundreds and thousands of people. And he's requested data analysts to go over the test data and get it processed and ready to send to the NHS, and we currently set all that up. We've sent a lot of volunteers to them already. It sounds like that's something that's really ramping up to be something quite big. And then another project that recently came in, doesn't even have a name yet, but it was a doctor that got in touch with us. Yeah, he's got a lot of chest radiography data, and he wants to analyze it to detect symptoms of COVID and the results of how much pneumonia has affected the lungs and things like that. So, I'm not a doctor. I don't know 100% what he's doing with that, but he's been looking for some computer vision specialists to help him with that in particular. So those are a couple of the projects that we have been helping with COVID tech support. Also want to give a shout out to Datakind, which has also been mentioned, I think a few times already, but we've been working with them as well. Traditionally, they've been about using data science for social change, but social change these days means helping with COVID, and they've been doing a lot of great stuff too. I'd say the main difference between us and Datakind is Datakind tend to work with bigger, more established charities, whereas we tend to work with new projects that have spun up, new initiatives, lots smaller charities, and sort of more speculative projects, I'd put it that way. But Datakind are fantastic. You should look at them. One thing I'm seeing as well with the kind of projects that have been coming in are projects. 2 months ago, there were a lot of very hacky projects that got to put together quickly. COVID tech support was one of them. But over the last couple of months, they've really matured. They've got sort of good products, if you want to call them that. And a lot of them now are moving into sort of scale-up mode where they are being used and they're trying to scale to more users. They're trying to reach more people. And therefore, they're looking beyond just those initial skills of, I need to set a website up. Now, some of them have data that they need to analyze and think about. So I'm expecting to see more sort of data science projects along those lines. Another thing I'm seeing more of as well is at the beginning of this, there were lots of volunteer-oriented services like help your community, help your neighbor, that kind of stuff. Those have fallen by the wayside now, and we're seeing a lot more projects around lifestyle and social distancing, because I think it's becoming apparent that this is going to be around for a long time. And so a lot of services are starting up to address the implications that that's going to have on life for a while. So with all this in mind, I want to highlight other ways that you can help. One of the ways is, I hope that from the projects I've described that they may inspire people in this conversation to start something new. As I've seen a lot of these projects start up, there's a very interesting startup-like ecosystem at the moment where new apps and services are just popping up all the time. There's actually a healthy amount of competition going on as well. I mentioned about volunteer apps. I think about a dozen of them popped up in the first couple of weeks of the pandemic. And what we've seen is the best ones are the ones that are still around, that are actually being used by volunteers, and the other ones have sort of fallen away. But that's a great situation because it means real good products are being put out there to help with this. And there's a lot of support as well from the governments with Innovate UK and the Tech Force 19 competitions. It means there is some money as well to support these projects, the ones that are doing well. And the thing that kind of really wraps that up is there is huge disruption in the world right now, which means there's a huge amount of opportunity to do something. Even a simple idea can have a massive impact because the world has changed. So in the first instance, if you have a burning idea, you shouldn't wait around to do it. You shouldn't ask for permission to do it. You should just go out and do it, because that's what a lot of other people have done. And you'll learn pretty quickly whether it's a good idea or not. And if it is, there's enough demand out there that'll pull you towards them, and hopefully your idea can make a lot of difference. One thing I would warn, though, for people who do want to start a new idea is just to make sure that you sound the idea out first. One thing I do see a lot of are projects starting up that are working on something that doesn't matter, or the project idea doesn't have a connection to someone who's experiencing a real problem and really, really needs that project. This is the reason I started COVID Tech Support in the first place, because I saw a lot of this happening. And I knew that there were lots of projects out there that didn't know to ask for tech help. And I wanted to make sure that people who did want to start projects or work on something meaningful could find those problems. And so if you don't want to start something yourself, or if you thought of starting something yourself and realized, actually, I don't think that's going to help, COVID Tech Support and Datakind are places you can go find those problems, and you can go help people who are asking for help, not just what you think may help. And I think in particular for data scientists, one thing that happened at the beginning of the pandemic was, everybody suddenly became an armchair epidemiologist, and everybody wanted to write a blog post or put up a website about tracking the death rate and RO and so on. People who are nowhere near as sophisticated as the work Russians been doing. These are the people we need to leave it to, because I think there has been a lot of noise out there regarding what the data can tell us about what we should be doing with social distancing and so on. And all that noise can actually be dangerous because people aren't getting access to information that's accurate and helpful and so on. But I hope one thing I've been able to show in this webinar is that there's a ton of projects out there that you can be using your data science skills to help with. You can find them on COVID Tech Support, you can find them on Datakind, and there's lots of ways you can be helping. And the final point is, you may not appreciate it, but you also have a lot of what you would consider minor skills, but that those skills are still enormously valuable to a lot of the people experiencing problems out there. And I'm talking about things like just how to set up a website or set up WordPress, or how to automate simple workflows, how to use Google Docs. These are things that, a lot of the requests we get are requests for that kind of help. I need to set up a form and collect data from my local community so that we can organize our volunteers to help the elderly. How do I do that? You don't need a new app to do that. You need a Google form and a Google Sheet and an email account. And a lot of the people organizing those things don't know how to use those tools. I mean, that's a very simple example, but we have all sorts of things in between, and even just some simple Zapier automations or Airtable, things like that, the kind of tools that we're used to using on a day-to-day basis. the people who are asking for help aren't aware that these things even exist and don't know how to use them. And there's been several times where, someone with our background spending an hour chatting to someone at a charity can literally change their world. So don't underestimate as well the skill sets that you have. It doesn't all have to be data science. There are still a lot of ways you can make a big impact. So to summarize all of that, there are 3 ways you can help. The world's turned completely upside down in the past 2 months, and we're going to see the effects of this for a long time. So the more you can help now, the more of an impact you can have on that and the outcome that we'll get. But yeah, the 3 ways to help are, in first case, if you've got a great idea, build something useful. And I stress the word useful there. The first thing you should be doing if you want to build anything is just to check it's useful, find some evidence that it's the right thing to be working on. But there are a lot of useful things you can be working on right now. It's not hard to think of something useful at the moment because everything is under such disruption. The second thing is, if you don't want to build something new yourself, you've got no ideas, that's totally fine. You can find other people who've been building things or other problems that exist by going to ContextCat.com or Datakind to find projects to work on. And finally, it's not just data science. You can contribute your general tech skills as well. Those are just as valuable and can really make a difference to a lot of the problems that are being experienced just now. So I'm going to copy and paste those links in the chat as well, but happy to take any questions.
That was really good. Thank you, Mark. Yeah, great cause, doing some really cool stuff. Just a quick question from my end, and this is thinking from the data science slant on some of the products or projects you mentioned in particular. I can't remember if this is called a Step Safe or Safe Step one that you talked about. Sounds very interesting and obviously really important cause, but very high risks as well. And given that the people working on these things are volunteers, how do you kind of sense check the work that a product that's being built before it does get released?
So it depends on the project. We get a wide range of project types coming in. On one end of the scale are big, well-established charities like Crisis who get in touch with us and say, we've got a project manager who's already been scoped out the requirements and all the rest, and we know exactly what kind of. We need a web developer, we need a data analyst, we need a front end, UI designer, etc., etc. The opposite end of the spectrum is someone coming in saying, "I've had a great idea, someone should build this," and it's a bit like, okay, and in that case, even if they ask for specific developers and so on, what I'll probably do is actually send them a user researcher or a product manager to speak with them to understand the requirements a bit more, scope out the project and see. In the case of Safe Steps, I could see from the research I did on them that they've been around for a while. Their app, they are an official charity. Their app was being used in care homes already, and the COVID aspect of it, was a new feature that came in with the beginning of the crisis. I'm not qualified to know if what they're planning to do makes sense or could increase the risk, but that's not. The thing here is they would be building this anyway. If I can assign them a good data scientist to help them out, they can figure that out together. But yeah, we try to help everybody who comes in, whatever way it makes sense. We're trying not to judge which projects are going to work or going to be safe. In some sense, we believe the market will decide that, and that's the best way to do that.
Yeah. So it's less a case of you guys building a product and then handing it over to them. They've already set out a bit of the roadmap for it, in this particular case anyway.
Exactly. In most cases, we send the volunteers over to them and then they handle it. They take it from there. In some cases, we'll form an internal team. I mentioned Crisis. They had a project where they had a warehouse that was full of essential goods, which they needed to get out to shelters across London. And usually people would come to the warehouse and collect goods for their shelters, but they couldn't do that anymore with social distancing. So what they had this idea of setting up a sort of web store but it had to be private, only for the local shelters, and all the goods were free. You just had to go and sort of order, and then they'd arrange delivery of these goods. So they came to us with this kind of, this is just an idea. We've got no idea if this can be built. And so we ended up forming a team of, firstly a product manager to go speak with them and scope it out. That product manager then came back and said, right, I need, these 5 roles to be filled. We ended up finding a web developer who specialized in e-commerce websites for WordPress. So he was like, I know how to set this up straight away. That team got working. They built a prototype in a week that they delivered to Crisis. Crisis started using that then with the local shelters. And from the feedback we've gotten from them recently, it sounds like they've scaled that up now, and that's something they're using on a regular basis. So in that case, we built a team to help them with that. But still, that team became embedded within Crisis. I'm not managing that team, for instance.
Yeah, that makes sense. We've had one question come through. Could you please share more details on the technical side of the projects? Are they cloud-based or hardware?
We get few hardware. They're mostly software. And I would say easily 30-40% of projects are technical in the sense, most of them can be solved with WordPress or Google Docs or something like that. You've got a local charity that just needs to put some process online. They've got no idea how to do it. It can be solved with off-the-shelf tools. And if that's the case, that's a win. Then another 30-40% of projects are, okay, this thing does need a website, or they have an existing website that needs to have some new feature added to it. Occasionally we have requests to build apps as well. But hardware, we've only had a handful of hardware projects. Probably the most prominent one we've had was a product called Getbox, which is it's a Wi-Fi, it's a home Wi-Fi router that connects to the 3G, 4G network. So the idea is that they're trying to get these built now and sent out to people like the elderly and so on who aren't connected to the internet and therefore are effectively shut off from the world at the moment. And getting internet installed for them, is a huge problem in itself. Whereas you can just send them this box, they can plug it into the socket, and it'll just start it'll connect to the mobile network and start offering them Wi-Fi in the home with very minimal effort needed on their part. So that's a charity. They're building these things for free and sending them out for free. So they asked us for some hardware specialists to help them get that system working. We've seen a couple of sort of health devices as well, but I'm not a healthcare expert, so I'm not 100% sure. And we've sent them some volunteers, and hopefully those are going okay. It's mostly software though.
Perfect. I think we've hit most of our time here, so really appreciate the talk, both of you. Thank you so much. I can see in the comments Musi has potentially a project that she'd like to discuss, Mark. So I believe we both Rushan and Mark would be keen to talk to people after the talk if they're interested in something they've talked about or some other ideas that they may be able to contribute to. So as mentioned, following the session, we will share a link to the video and also some contact details for both the guys, so you can get in touch. But on behalf of Matt, Xcede, and everyone speaking, thanks so much again for the talks. Mark, that was great. Rushan, fantastic as well. And we hope to do another one soon. So if anyone would like to get involved, has a topic they'd like to share, COVID related or otherwise, we're really keen to hear from you. So please get in touch with Matt and I in due course. But thanks for attending, everyone. Much appreciated.
Thank you, guys.
Cheers, everyone.
Take care.
Take care. Have a good day.
Okay, cheers. Bye-bye.